Allora, abbiamo parlato a lungo di trattamento dei dati, quali sono i dati importanti, eccetera. L'ultimo tema, abbiamo due flash sul futuro della sorveglianza aerea. Il primo a parlare è della Lockheed Martin, è Charles Gulledge. La Lockheed Martin è inutile descriverla, 100-150.000 persone circa. Ho trovato qualcosa come 250 fotografie nel web appena ho fatto Lockheed Martin. Chi parla a nome della Lockheed Martin Information System and Global Solution, che è un gruppo di solo 28.000 persone che fa solo 10 miliardi di dollari di sales e che è diviso in tre segmenti: Airborne ISR, C4 e ISR Data Management e la parte Sharpening and Technical Edge. La richiesta che abbiamo fatto è soprattutto di concentrarsi sulla elaborazione dei dati e parlerà Charles Gulledge. Sorry, I made the introduction in Italian, but you understand. After one day like this,
Absolutely.
You understand Italian.
Perfecto. Good afternoon. My name is Charles Gulledge. I'm with Lockheed Martin C4ISR Systems out of Denver, Colorado. Thank you very much for the opportunity to come and speak with you today. What I'd like to share a few thoughts on is C4ISR Systems' vision of how multi-int manned airborne ISR is a big part of the future of joint ISR. As you've heard all morning and into the early afternoon, what the user needs and the users in the audience, I think, will agree, is you need multi-int data from as many sensors as are relevant. You need that data to then be interoperable within itself and to other assets that you have. You need it to be timely and accurate, and you want it to be hosted on an architecture that's open, that allows you to bring other things in, other people's products in. So a simple solution, a simple problem, right? Not exactly. What is the solution? The solution obviously is not a single sensor platform. It is a system of systems, or an enterprise that transforms all of that data into knowledge so that you as a user can quickly act on that. And when you get that solution, you will have a capability that is a force multiplier. So how can C4ISR Systems help define that solution? Well, what our operating principles is that we don't have a single solution that meets everybody. There is no one size fits all. We have a set of operating principles that we utilize to work with each and every customer that we support. And the product that we deliver is a complete integrated intelligence enterprise solution. Whether it is a single software package on a COTS computer, or whether it is a Gulfstream G550 with all the different sensing types, we still treat it as an enterprise, because we want to use a common architecture to support the data manipulation, the user experience, and by doing that, we can then bring these pieces together as we build up a solution for each user. So you can see there our principles that we work with. The first thing we look at is the mission system to support a user, and that is our Intelligence Enterprise Core System. You've heard several presentations this morning talk about service-oriented architecture. Our mission system is a SOA compliant architecture. You've heard discussions about STANAGs. That architecture, one of the first things it does with any data is to normalize it into STANAG compliant formats for storage and for distribution within our own enterprise, which then supports plug and play with other capabilities. So once we get that mission system sized for a customer, the next thing we look at is what is this customer's needs as far as sensors. So we look at their operational requirements, and then we work together to decide what is the right sensor mix. Then we go to industry. Now, Lockheed, we do produce some sensors, but really we go out and look at the industrial base. What is the right sensor? What is the right company to bring to that customer? Then we take a look at the platform. Is this land-based? Is it airborne? I represent the airborne community. Is it ship-based? So once we've identified these aspects, we start to put together the solution for that individual customer's needs. But as you've also heard today, if you can't move that data, it's just a science project. So then we have to look at what are the communications needs. Do you need SATCOM? Do you need line of sight, Link 16? So again, we have a set of industry partners that we work with. Again, Lockheed also makes some of the products. Celix ES now, I almost said Celix Comms, but Celix ES, we've integrated your radios, L3 Communications, so we have a lot of industry partners that we work with. When you bring all of that together into our intelligence enterprise, the benefits that you get, that a user can take advantage of, is you now get faster, more robust situational awareness because you're able to move that data, whether it's small data or big data. You're able to get that data, classify it, normalize it, store it, and reuse it. You also get improved probability of detection, especially in the multi-ent arena. If you're flying a mission and you've only got cameras, it's sometimes often a needle in a haystack if you don't have some other indications as to where your target is. So with a multi-ent, maybe a SIGINT sensor or a hyperspectral, it gives you the additional capabilities to improve your probability of detection. Also improves your geolocation because you can then correlate / fuse data from multiple sensors and refine your location, and you're going to get that location faster. And then finally, extended range of detection. Again, if you're flying with a camera, you've got to be pretty close. But if you've got an ELINT sensor on board, you might be able to detect your target at much greater ranges. And then, being in a manned platform, you can quickly react to what you're seeing in the environment. I think you've heard just about every presenter today, and I thought it was fantastic because I saw some graphics I'd like to steal, and please, anyone's welcome to these as well, about data to knowledge. It's the name of the game these days. What I'd like to talk a little bit about here is from a multi-ent airborne ISR perspective, the data coming in the front end can be overwhelming. One of our configurations that we call Dragon Scout flies with a synthetic aperture radar, an EOIR camera, a comment collection system, an ELINT collection system. You can imagine the quantities of data coming in the front end of that. Individually, the operator assigned to each one can operate, and he's a subject matter expert, but he gets overwhelmed. So what we try to do is the first step in transferring that raw data to knowledge in the orange there is, first of all, it has to be normalized and put into a visual representation. And that first step also is to automate. Put in automation tools that takes the routine tasks, declutter, so that what's left for that operator or for the mission commander is a set of relevant data to the problems that he's trying to address on that mission. The next step then, moving into the blue column, is to take that information that's been created now and overlay it with external factors. Data that you get from other systems, from Link 16 offboard tracks, data that you get from coalition assets. Now you are being able to bring additional pieces of information, not raw data, but pieces of information that either validates what you've seen or helps support it and then finally transforms it into that knowledge. In that last green box there, that is where you're bringing in non-ISR type data, weather. We heard earlier talking about how weather can play a big part on turning that data into knowledge. Change history. What has changed in this area from the last time you were surveying it? The order of battle. So a lot of different data types, pulling that all together, and what you then can present to a commander. So when you push that data out over your common data link or over your link 16, isn't just more data clogging the pipe. It's knowledge that can be used to act on. Within C4ISR systems divisions, we have a fairly wide breadth of products or solutions that we offer to our customers. About 3 years ago, we started branding them. Cool graphics, first of all, but more importantly, it allowed us to group capabilities and talk to our customers and our users. It allowed us to narrow down to solution sets more quickly. Won't go into each of these, but you can see that they range from a full, integrated air and missile defense, Dragon Dome, down to Dragon Star, which represents the category that our airborne multi-ent laboratory is part of. I'll talk a little bit about that next. But you can also see some examples of these systems as we've deployed them for customers down at the bottom. Earlier when I mentioned our operating principles of how we work with a customer, this is an example of a cooperative development approach that we used. We took in a customer's requirements, and then we used those to configure a test bed, or in this case an airborne multi-ent laboratory. We have a Gulfstream G3 aircraft that we outfitted with a architecture and with a set of sensors that matched basically a specific customer's requirements. Then working with that customer, we fine-tuned some of the onboard equipment, and ultimately we contracted with that customer to fly it as a service. And we have that customer operating it, all of the sensors in the back end. We operate the aircraft and maintain it. And by doing that, we've allowed the customer and Lockheed to benefit from flying the actual platform, refining concept of operations, because you can imagine in the U.S. terminology, at least we talk about fighting a system. Learning how to fight a multi-ent jet is quite different from other platforms and other capabilities. So we were able to then, we have been able to generate concept of operations, a concept of employment. But what we've also done is allowed the customer, he has been able to go back to his basic requirements document for his core requirement and refine those so that now when he procures that, the waterfall effect or the spiral development, we've mitigated some of those pitfalls so that he knows what he's asking for now in his requirements. And then ultimately we'll fill that system cooperatively with that customer. Another example, I mentioned our airborne multi-ent laboratory. It just so happens that the Italian MOD is currently flying our airborne multi-ent laboratory. They've been flying it for about 1.5 years now, and it has ELINT, comment, and EOIR sensors on board. They've, ourselves, along with the Italian MOD, we've achieved 97.7% availability of that system over 4 90-day deployment periods. During that, we've had 291 sorties, demonstrated surge capabilities. Again, with that platform, during a 6-week period, we flew over 236 flight hours. We've made multiple deployments out of Project Mare to UV-12 in Norway, to Sardinia, 4-star Vega. It's been on operational demonstration flights in the Eastern Med, Western Med. It has a very robust communications package. It has a line of sight CDL, tactical VHF, UHF. Again, thanks to Celix ES for helping us with tactical radios. And Link 16 capabilities via the MIDS terminal. And it also has a ground system, a portable ground system. We've taken our portable ground system and worked with the Italian MOD and actually have now configured 2 fixed ground systems with them using our customer furnished equipment. So again, in this case, it worked out quite economical for the end user that they were able to take advantage of commercial hardware that they purchased. We just gave them a list, and then we integrated the software into it. So it's been a very successful endeavor. And again, working through the cooperative nature, both parties have learned tremendously from it, and we look forward to the next steps. The next thought I'd like to share with you is how manned airborne ISR fills a critical role in joint operations. You might recognize some of the pictures. We built this network to represent how the joint ISR assets, you can see there in the second column, feed into the network within the Italian MOD. And that then supports all of the major operations across the different services, as well as into NATO operations. The enterprise architecture that's in place in a multi-ent manned airborne ISR platform provides the capabilities to take data from the platform, from any of the individual services that it may be supporting, and then provide knowledge back, whether it's through a data link directly to a handheld for a ground unit that's in the field, whether it is through a Link 16 network to other airborne assets. It feeds it to the shipborne assets, again through Link 11, Link 22. So all of those capabilities, those communications capabilities, allow us to push that data to all of the assets. Now, going back to the enterprise nature of it, by being able to take different data types, normalize them, and then make them available, it also allows us to quickly integrate with NATO operations as well. What the architecture supports, the service-oriented architecture supports then is, for UV-12, within 1 week, we were able to implement all of the required data formats to store our data into the coalition shared database, because it's working on normalized data into STANAGs. So it's very easy, very quick, using commercial software. Another aspect of this is we have been moving constantly towards free and open source COTS products, so that our customers aren't tied to very expensive licensing fees. So in summary, it's a force multiplier, because with one or more manned airborne ISR assets, you can redeploy quickly. You have, by having the crew on board, you avoid some of the airspace compliance issues, or you're able to quickly respond to them. So you can redeploy quickly to assets or to areas as needed. You can retask quickly because you have the different sensors on board. And with the multiple sensors on board, you can then quickly close on locations, identities. And then finally, NetDragon, I didn't mention that. That is our lease, our ISR as a service concept within the Dragon family. And with that concept, it allows our customer base to try before you buy, basically. So you work with us, we put together a configuration, we agree on a use concept, and then whether you operate it, we own it, we operate it, we have all of those different configurations. Thank you very much.
Thank you very much for your interesting